Welcome to January 19th's LeetCode Challenge. Linked list cycle 2. Given the head of a linked list, return the node where the cycle begins. If there's no cycle, return null. There is a cycle in a linked list if there is some node in the list that can reach again by continuously following the next pointer. Internally, pos or position is used to denote the index of the node at the tail's next pointer is connected to the 0th index. It is -1 if there's no 0. Note that there's a position pos that's not passed as a parameter, so do not modify the linked list. So we're given head here starting at 3, and we have a linked list here at position 1. Note that is not connected to the, so the position is not passed as a parameter, so therefore we're just given head. Therefore we want to know whether this is a cycle or not, right? The linked list is a cycle, and we know that the end tail pointer here, -4 value, -4 is pointing to position number 1. So there's a cycle in the linked list where the tail connects to the second node. So therefore we want to return the node where the cycle begins, and the cycle begins probably at index 1. And there is a cycle here because 1 points to 2 and 2 points to 1, therefore the position here is index 0. Therefore, the tail pointer points to index 0, therefore there is a cycle. This is a linked list that has a cycle, and it's pointed to the first node. And we have a single node here. The head is of size 1. The position is -1, that means there is no, and -1 is there's no cycle. So therefore, there's no cycle in the linked list. And that's pretty much it. So in order to solve this, a classic way of figuring out if there's a cycle in a linked list is using the good old fast pointer, slow pointer technique, also known as the turtle and the hare, also known as, I believe it is called Floyd's cycle detection algorithm. Alright, it's known by many names. But yeah, it's basically the idea is to move one pointer that's fast, or the hare, the rabbit, and that moves twice next, that's using next twice, and you have the turtle pointer, the slow pointer, which goes slower, right? And if you have the fast pointer moving at the slow pointer, fast pointer moving, and then the slow pointer also moving, if the fast pointer ends up meeting or touching the slow pointer, that means there is a cycle. That's how you check the cycle, and then therefore you can reassign to make sure that you return the node where the cycle begins. So we'll start off. So let's say we can use turtle or rabbit or fast and slow. I'm gonna use fast and slow here. Equals slow and equals head. Alright, we're gonna initialize that to the node. And we want to know that develop a boolean here, cycle. So if it's a cycle, we return true. If it's not a cycle, we return false. So we have those two so far. Now, while the fast pointer and the fast pointer.next exist, we want to move the slow pointer such that slow pointer next, right? We move the slow pointer by 1. We want to move the fast pointer by 2. So fast.next next. Next. So there. Next. So the slow pointer moves next once, and the fast pointer moves next twice. So therefore, if whenever we have the fast pointer is equal, also say if the slow pointer is equal to the fast pointer, and then we know that there's a cycle that exists, so therefore return cycle equals true, then we break from this. So this is basically pretty much determining whether we have a cycle or not. Remember, the position value or is not past its parameter, so we have to figure out whether it's a cycle or not. Okay, we can figure it out whether it's a cycle or not. Next thing we're going to do is, if not a cycle, cycle. Return null or none in case of Python here. So we took care of that. So if there's no cycle, therefore return none or null. And then next thing we're going to do is return the node where the cycle begins. How are we going to do that? So we want to determine that, let's see, we have let's redefine a slope pointer again. It's going to be equal to head. So while we have our slope pointer is not equal to, actually, it's using 3 pointers. Let's call this pointer, I guess. It's not equal to slope pointer. So what we have here is we developed another pointer, right? So now we have basically fast pointer, slow pointer, and just a pointer where we're at to determine where the head is, right? The node where the head cycle begins. If while the pointer that we created equals to head is not equal to the slow pointer, what we want to do is move both slow pointer, the pointer is equal to pointer.next, and the slow pointer to slow pointer.next. And we just kind of keep on moving those 2 pointers until they are equal. And then we just not equal, but they're the same. Then they will exit this while loop. If they are the same, that means that they are the node where the cycle begins because both pointers are on the same dot. Therefore, we want to return the slow pointer. Run the code. Let's see if this works. Okay, submit. So I guess when you return the head, it will automatically convert it to a string. Okay, accepted. It's not the fastest, but it's big O of n. So we have because we iterate through each pointer, which points to each node in the head. So therefore, it's big O of n. We have 2 while loops. These 2 will run consecutively, so they don't affect each other. Memory space complexity is big O of constant space, because we store everything inside the actual list to begin with, the head. So big O of n for time complexity, and big O of 1 or constant for space complexity. All right, there you go. Have a great day, guys.